it's there. That's the only place it is because it's just that.
So
Yeah.
write it.
So write it or take a picture, but if you need to write it to remember, write it. So in 7.1, it's the graphing and substitution. There will be one question in which it tells you you have to graph, and then there's going to be other ones in which they're mixed in, and you could choose whether you use substitution or elimination. But there will be one in which you have to graph.
Are we going to get ruled? Are we going to get like graphing paper?
If there's a graph on there for that question.
And it'll fit in the graph because a lot of
Well, I
times
mean,
we get-
sometimes it goes off it, but you should be able to count it out. Like you should be able to find the intersection. Yeah. And remember for those, there's special cases. So that's in here. Like if you're doing the graphing, the special cases are that if the lines are parallel, there's no solution. If it's the same line, it's all real numbers. And for elimination and substitution, the special cases are if there's no variables, what's left is true, then it's all real numbers. If there's no variables and it's false, it's no solution. So that also worked for substitution. So again, you're going to get, I think there's 3 at the beginning in which you get to choose between elimination or substitution. One that will force graphing. And then there are 3 total word problems. 1 interest problem, 1 break-even problem, and then the third is a mixed bag. It could be your geometric where you had to know the perimeter, that kind of stuff. It could be where it's ticket sales. It could be like, I don't know, which one did you guys have? You had a perimeter one, right?
Yeah.
On your quiz, but I gave one that was like had the calorie intake on French fries and cheeseburgers. So like there's different stuff like that. All of those you have to set up a system and then solve it. So that's one that's like a rotating type. For the interest, you're obviously going to get 2 accounts. This one is whatever percent. This one has whatever percent. So you had one like that on your quiz as well. And then for the break even, the difference this time is on the quiz, you didn't have to set up your cost function and your revenue function. And on your test, you're going to have to. So you're going to have to set up a cost. You're going to have to set up a revenue and then set them equal to each other. And then find the number of units and always round up. So even if my answer was like 101.1, I would round it up to 102 for the break even.
What is can you go to elimination?
Go to elimination, you said? Yeah.
What is the no variables?
So if those are your special cases, if no variables, if you cancel out the variables, and what's left is a true statement, it's all real numbers. If what's left is a false statement, it's no solution.
So for break even, they tell us that to start up the business, it's a certain amount.
Yep, and then it costs so much to produce each unit, and then you can sell each unit for however much. So the selling of should be more than the cost. That's one way you can know the difference.
How many times we have to sell it? That'd be X.
No, that'd be like the price you can sell it at. So like if you're building something and you can sell it for $10.50, that's 1050x, yes. And that's your R, that's your revenue. And then the cost, if you had to pay $5,000 and it's $6 each, then it's 5,000 plus 6x. And then you just set them equal to each other, solve it, and if it's not a whole number, you bump it up. So the spacing on it's going to say R equals and a line, C equals and a line. You're going to give me the equations, and then you're going to have to give me the number of units. Yep.
What if it's after no variable on the second one?
It says and true. So on your quiz 7.3, you had the new 2 variable, like that one where you had 3 variables, 3 equations. That's come off the quiz. So if you're comparing it to your quiz, then you can take off number 6. Number 7, you'd be solving using a matrice instead of the systems that you used. So you can actually take and do that whole question again using Gauss-Jordan and Gaussian elimination. Right, that's the equilibrium point. So I took that off. And like number 7, you're doing it differently. Right. You're using Gaussian elimination with you're using the matrix.
We're not allowed to use it any other way. Solve
It specifically says use Gaussian elimination with back substitution, and then it says rewrite your row echelon form and then solve it using Gauss-Jordan. So you're taking that problem, you're solving it using the back substitution, and then you're continuing to get the last 3 zeros and getting it Gauss-Jordan.
Can you scroll down? Thank you.
You're welcome.
Can you go over,
The names, like I don't get.
Yeah.
Yeah.
like, which ones are like the top three and bottom?
Mm-hmm.
Which ones are just
The reduce is the wrong.
Correct. Was I recording before? Yeah. Okay, you want your diagonal of ones with the zeros below. That's the first one. I don't even remember what number it is, but it's the second to last question.
Solve, and then you would get 3 equations.
Yep. And then you do your triangle system, and then you'd get your answer, your x, y, z. Then the directions are going to say rewrite your row echelon form from the previous question and solve it using Gauss-Jordan, which means now you got to get the zeros above and below. So the answer, I think it's 10 and 11 or 11 and 12 to those questions are going to be the same if you do it correctly. But for Gauss-Jordan, you have to keep going. Yep.
Or you could just do Gauss-Jordan with like what you already had from Gauss.
It's what you're going to do. It's what you have to do.
Yeah, and then just turn those numbers that you had on top of the ones into 0.
Correct.
Okay, so
Yep.
just keep on going.
Correct.
How would you get the second one to be 0 without making the first one 0 for Gauss-Jordan?
So once you get the ones, to get this one, we use these two. To get this one, we use these two. And to get this one, we use these two. If you do it that pattern, you'll never lose the other ones.
Okay.
This is super important. Shh, listen, guys. There are 2 calculators that look as though they're scientific, but they actually have matrix capability on them, and you cannot use them. And they are these 2. So if you have either of these and you've been like using these to practice your scientific, stop. Because you can't anymore. Okay? They literally have a matrix button like this one. I don't even remember where it is. The one on the right, it literally says matrix. So everything we did with the graphing calculator, you could do here. And then I forget how you get to it on the one on the left, but you can. So it is just not an option. So these 2 are not. Okay? If you are unsure, you can always ask me, like, is this one okay? Like, Timmy, hold yours up. This one, totally fine, right? Like that TI, whatever, the basic one like that. This one, totally fine, okay? And if you don't have one and you can't borrow one before Wednesday, then you're going to use the lockdown calculator. Like, that's your option. Yeah.
For 7.4, do we have to show the rows and the transformation we're doing?
Yes. I'm going to be so... literally, the directions will literally say in order to get full credit, you have to show every operation and the step. So as you build, I would say, like I saw somebody do it last week, and I was like, I tend to be a little bit less organized. They kept rewriting the matrix on the left-hand side, like rewriting the matrix all here, and then doing whatever to it over here. And then they'd rewrite it over on the left. So they kept like working through that system, because you're going to get one piece of paper. You're probably going to have to go down, and then you're going to come back up again sometimes and keep working. So you got to work at 1, pay attention to your spacing so we're not killing 800 trees. 2, don't get all over the place, right? So like I would write the matrix and then whatever I got to do first, and then rewrite the matrix and then whatever I got to do second, and then rewrite the matrix, whatever I got to do third, until you're complete. And then you can write your x, y, z equals your number, your y, z equals your number, your z equals your number, and then you're going to solve it. And then it's going to say take your row echelon form, so whatever the ones and the zeros below are, and then let's just say it's this. You're going to rewrite that on the back of the paper very carefully so you don't lose off a negative or move a number. And then you're going to continue to solve that to get the 0 here, here, and here. And then that answer will be the 1, 0, 0 with your x, the 0, 1, 0 with the y, and the 0, 0, 1 with the z. And then again, that answer. So the answer to those questions should be the same.
We take it Wednesday?
Wednesday, yep.
So yeah, I have a question.
What? Yeah.
So to get rid of the 4, for instance, now that we're doing the second part, I would multiply the last row by -4.
Correct.
And add.
To get rid of the 3, last row by -3.
Yeah.
Then add. To get rid of the 2, second row by -2.
That's so
And add the first.
Is
It
there a
could
certain
be.
pattern we have to
How
go
else
by?
would it be?
Mm-mm.
Because I know how in the bottom you go straight down for 0.
You don't have to, but if you come this way all the
Is there
time.
gonna be one
Sometimes
that's-
things are faster though. Like you might look and this is like a -1 and this is a +1 and you want to add these and get the 0 then. You can do it. It's not you have to go in that order.
Is
Yeah.
it gonna be one that it's all zeros at the bottom?
No. There's no solution. There's no all real numbers. There's no all zeros at the bottom.
How much is that question worth?
So the first part is 20 points, and then the second part is 10. Yeah.
And it's like hit or miss. You get it.
It's not going to be hit or miss. You're going to get it.
That hurt my
No, but I'm talking about like there's no partial credit. Like,
No, there's partial credit. So I'm gonna do both questions from your quiz, the partial and then the bonus one that had the repeated factor, because it's been a little bit since we did that. Okay.
I have a question. Is the bonus going to be your regular question?
Yeah. The bonus from your quiz is going to count as a regular question from on your test. So we did, like I said, everything on the quiz, like up to, with the exception of that 7-3 and the equilibrium, are gonna be on your test. If you want to discuss with my I period or J period, what did your word problems look like? Feel free. Those are extra problems, right? If you want to take your variable 3 system question, what was that, 6, the big one, and do it with a matrix, feel free, because you're going to already know the answer, okay? And then one of the questions on your quiz was partial fractions, where you just had 2 terms. You were going to get one of those, and then the bonus that had that repeated factor, you're going to get one of those. So I'm going to work them both out. So this one, the first thing you want to do with partial fraction decomposition is factor the bottom. So I look at the bottom, and this would be x minus 4 and x plus 2. You could have done x plus 2 and x minus 4. The order there doesn't matter, but the negative's got to go in the 4 and the positive's got to go in the 2. Then what?
Then you separate them.
Good. So it'd be a over x minus 4 plus b over x plus 2. Then what?
You put the x plus 2 with the a.
Good. What's missing from the bottom, right? I multiply by the top. So a gets the x plus 2, b gets the x minus 4.
Then you set the numerator equal to.
Good. Just the numerators. So, yeah,
Let's say I set it up differently. I had the a x plus 2.
totally fine. At the end, the right number is going to go over the right denominator. The order doesn't matter.
The one where you distribute is repeated.
Correct. Yep.
Would there be any words like these?
No.
I took that off and put on the repeating. That was the trade-off. Initially, there was 3, but time-wise, I took it off.
So
Okay.
there's no C.
So there's not 3 no, yeah. Okay, so now I want to cancel them out one at a time. Or you could go like, I think it was Vicky, right? You liked to distribute, which you could do the long way. It's totally fine, but we'll save that for the repeated factor. Yep. Adriana, you have a question or no?
Isn't it gonna be one with 3?
There's not one with 3,
Is it that
with a repeated factor, yes, but not 3 different ones. Yep. All right, so then this, I can either set this equal to 0, and I would get 4 and negative 2, or just look at it and see what's going to cancel out. So the first thing I'm going to do is do x equals 4, and then I'm going to come back here and do x equals negative 2. So 4 plus 3 equals a, 4 plus 2. Now the better you get at these, the easier this step is, because I already know 4 is going to cancel from here. I'm not even going to write the b. So I just saved myself a step. If that throws you off, then you do plus b times 4 minus 4, and then you get your 0, okay? But you actually don't need that step. So I get 7 equals a times 6. Here's my 0, just the b is gone. And I get a equals 7 over 6. Be careful on that step. People tend to divide by the wrong side. You get going and you divide both sides by 7, which is wrong. That's a silly mistake. Then I repeat that whole process with the negative 2. So negative 2 plus 3 equals, again, I know this is going to be negative 2, and that would be my 0. I don't have to write the a. If you need to see it, write it. 1 equals, this is gone, b times negative 6. Divide both sides by negative 6. And b is negative 1/6. Now I plug them back in. So the a goes over the x minus 4. So 7/6 goes over x minus 4. And the b, negative 1/6, goes over the x plus 2. Now you cannot leave a complex number. So I can't leave a fraction within a fraction. The 6 can come down for both of these. and I get 7 over 6 times x minus 4 minus, the negative comes in the middle, 1 over 6x plus 2.
Do you distribute?
No, don't. It's an extra step you don't need to do. If anything, you want to factor out, like WebAssign liked the 1, 6 factored out, I would take that answer, but you don't need to distribute, so don't waste your time doing it.
So we give it like the right one.
This or this would be both marked wrong. I mean, right.
Right.
Right. You just can't leave that. Easy stuff, right? You just need a little refresher, good practice. You'll know what you're doing. You'll be fine.
I need the bonus.
Yeah.
Is there-
This was the bonus.
Is it gonna be
The
like that?
bonus is gonna be
And how much does it work?
What do you mean like that? Like repeated factor?
That
Yes.
This one was harder than the other review factor questions on the review. Like I thought this one was hard.
Because it was a repeated factor. What do you mean?
No, like I thought it was harder compared to the other repeated factors.
What does repeating?
The review ones I thought were easy.
I feel like the one was like this on the review today. What does what?
Repeated factor.
Repeated factor means I'm going to factor this, right? So I factor the bottom. I take out an x, and I get x squared minus 2x plus 1. And then you can factor that again, right? X times x minus 1 and x minus 1. So that's what it means, repeated factor. That one factor gets repeated twice. Technically, that would be x times x minus 1 squared. So you could also see it like that. That also is a repeated factor because it's something raised to an exponent. So these are the ones you have to build up. I can't make it a over x minus 1, b over, or a over x, b over x minus 1, and c over x minus 1. I'd never get an answer that would actually work if I work the other way around. You have to build up to the x minus 1 squared. So the a gets the x, the b gets the x minus 1, the c gets the x minus 1 squared. You got to build up to it.
Does the C require an X?
Yeah,
So this is one with, there would be 3.
correct. Now you're comparing this to this whole thing. So what's missing from just the x is x minus 1 squared. You could either write that as x minus 1 times x minus 1 or x minus 1 squared. It doesn't matter. What's missing from b's x minus 1 to the original is the x and the x minus 1. And what's missing from c's denominator to the original is just the x.
To which original?
To this. We always go back to the factored form. Like you're comparing this denominator to this, you're comparing this to this, and you're comparing this to this. Whatever's missing from it is what you multiply the top by.
What would be effectively a bonus again?
No. You're welcome. All right, so now I multiply that all out. This x minus 2 squared, we already know is this. So save yourself the trouble of re-foiling that back out. So this is x squared minus 2x plus 1. So that's a times x squared minus 2x plus 1 plus bx times x minus 1. I'm going to eventually distribute that, but I'll just wait another step. Plus cx, and that equals my numerator over here, negative x squared plus 3x plus 3. Now the process of plugging in, like what would make that 0 doesn't work anymore, because if I did 1, it would always cancel out a and b. I'd never be able to solve for a or b. So this is why we do this different. We're going to distribute the a. We're going to distribute the bx. So negative x squared plus 3x plus 3.
How did it become the x? Oh, never mind.
You good? Yeah? Okay. Ax squared minus 2ax plus a plus bx squared minus bx plus cx. Now we do the coefficient grouping. So we group everything that has an x squared. So negative x squared here equals ax squared, bx squared. I would even go through and cross them out or circle them or do something so you know those are gone. Then I grab all the x to the first. So 3x equals negative 2ax minus bx plus cx. So all those are gone. And then the last one is 3. And the only constant is a. So I already have a, that's 3. For the other two, you want to cancel out the variables, so I want to cancel out the x's, right? So I'm going to divide everything by x squared here, not negative x squared, x squared. And I end up with negative 1 equals, this one's gone a, this one's gone plus b. For the second one, I divide everything by x. So the x is gone, it's 3, negative 2a, the x is gone, minus b, the x is gone, plus c, the x is gone. And I have a triangle system. I already know a is 3. I'm going to plug that into the one with 2. Oops. Solve for b. And then I take the a and the b. 3 equals negative 2 times 3 minus a negative 4 becomes positive 4 plus c. 3 equals negative 6 plus 4 plus c. 3 equals negative 2 plus c. And c equals 5. And then I plug them all back in. So a goes over the x. B is negative 4, so the minus goes in between, goes over the x minus 1. And c is the 5, and it goes over the x minus 1 squared. Yep. So I would get the 1 first, then the 0, then the 0, then the 0, right? To do this one, you can combine it with either row. I can do it with the top or with the bottom. What? I'm going to work out this one. He asked me to write out the steps, so I'm doing that. This would be just general. To get this one, you have to use row 1 and row 3. Is that what you mean by steps?
I meant like how we are expected to do on the test. Like.
Oh, yeah, I'll show it like, yeah.
Like,
yeah.
Because I don't know an organized way to do it, because when I do it, it's like chaos. That's what I was asking.
Yeah. I'll do it that way. This one we get row 2 and row 3. Then you have your ones and you're done with you're done with Gaussian elimination with back substitution. When you go back to do Gauss-Jordan, you're going to have to get this 0, and for this one you're going to do row 2 and row 3. Then you're going to do this 0. Well, you don't have to go in this order, but when you get to this 0, you're going to have to do row 1 and row 3. And this 0, you're going to have to do row 1 and row 2.
I'm confused how we get.
If that confused you, then ignore it and just
No,
practice.
I'm just confused how to do it. For number 5, like the 5.
Well, don't do this because this is not a real system, so I don't even know what the solution is. We're going to do this one. So the first step is obviously rewriting the matrix, right? So I took your question. This was 7 for one of the quizzes. And I rewrote it in matrix form. So my first goal is to do what?
To get the top left to 1.
Top left to 1. So I technically could do 2 things. I could I could move row 2 and row 1. That's the easiest thing to do. If you didn't have row 2 there, you could also move row 3 there and then multiply by negative 1. So I'm just going to switch row 1 and row 2.
Once we remove row 1 and row 2, we have to say row 2 is actually row 1 now.
Well, that row 2 is the 4, negative 2, 2. Now row 2 is
Now
4.
row 2
Right.
is 4, okay.
The row formerly known as 1 is now 2, yeah. Okay, so now I want to get a 0 where the 4 is. I can do negative 4
Could you have added row 2 and row 3?
to get a 0 there. Yes, and I will do that next.
Doesn't the 4 have a negative?
No. Mine doesn't.
I wrote wrong.
Yeah. So negative 4, row 1 plus row 2. So I'm going to do negative 4 times this. Negative 4, negative 16, positive 4, positive 8, plus row 2. 4, negative 2, 2, negative 8. 0, negative 18, 6, 0. And that's going to replace row 2. So row 1, 1, 4, negative 1, negative 2. 0, negative 18, 6, 0. Negative 1, 2, negative 2, 8. Now I want a 0 where the negative 1 is. So I'm going to add row 1 and row 2. I mean row 3, sorry. Row 1 plus row 3. So 1, 4, negative 1, negative 2, negative 1, 2, negative 2, 8. I get 0, 6, negative 3, 6. I'm going to replace row 3 with that.
This is just Gauss ordinate.
This is Gaussian elimination with back substitution. I haven't even gotten anywhere yet, but I'm going to stop at Gaussian elimination with back substitution.
So now are you going to try to get the 18 out?
So if I look here, right, if I would normally go to the 18, but if I do negative 1/18, I'm going to have a fraction there.
But can't you multiply 6 by 3 and then add?
The bottom, yes. So I would go that way. Instead of getting the 1 where the negative 18 is, because that I only want to do if it's easy.
Wait, can you say this?
Yep. I could, normally we try to get this 1 before we get that 6 so that we make that an easy cancellation. But it's not going to be. It's going to be 1 and then it's going to be, I have to do 6 times 1/18. So I end up with a fraction in that second spot. So I don't want to do that. So the easier way to do it is I want this 0. That's my ultimate goal there anyways. So I'm going to multiply row 3 times 3 and add it to row 2. So 3 row 3 plus row 2 to get rid of the 6. So 0, 18, negative 9, 18 gets added to 0, negative 18, 6, and 0. 0, 0, negative 3, 18. And that replaces row 3.
Could you also do 1/2 R2?
Yeah, it still just makes it. Yeah, you mean to cancel out the 6? Yeah. Now I need these, right, to finish off that bottom row. I need that negative 3 to be a 1. So I'm going to multiply by negative 1/3. So 1, 4, negative 1, negative 2, 0, negative 18, 6, 0, 0, 0, 1, negative 6. And I have my z already. If at that point that z is not a whole number, you did something wrong. Stop there, go back. Don't keep going unless you're completely running out of time. And then at least you have an answer. It's better than nothing. But
Why did he do
if z is not a whole number, you did something wrong. The big ones are whole numbers. Like the systems of the equations in the beginning of the, like 7-1 and 7-2, you might get a fraction here or there. But your Gauss-Jordan and your Gaussian elimination back substitution are all whole numbers. At least on the ones I made for Wednesday. I haven't even started with the makeup. So maybe that's incentive to be here Wednesday. Okay, so now I need a 1 here. Where that negative 18 is.
So 1 over 18.
I can do negative 1/18.
It's not really messy.
Yeah, it's not that bad. It's only a half, but yeah.
Excuse the interruption. Brian Hunter, please report to student services. Thank you.
And why did you do negative 1 over 18?
Because I had to get the last thing for Gaussian elimination with back substitution is that 1.
But isn't it negative 1/3?
Yeah.
Oh, 1/3, sorry.
What?
That's a 3. 6 into 18 is 1/3. That's so sloppy, sorry. So that is not a fraction in my answer. That is a fraction in the system. That is possible, especially depending on how you do it. You could do it completely different from somebody else and bring in fractions that I didn't even get when I do the key because you do it differently. Sometimes they're unavoidable. That time they were, but I would wait as long as possible to get it. Now you have to do your system. So my system is x plus 4y minus z equals negative 2. y minus 1/3 z equals 6, and z equals -6. I'm going to back substitution this to get to the answer.
How do you know you're there though?
How do I know? Because I got my diagonal of 1s and the zeros below.
You don't have to get the top yet.
No, then after I get this answer, I'm going to rewrite this system on the back of the paper, and now I finish using Gauss-Jordan. Get the other zeros. Yep. All right, guys, do the please do your review so tomorrow you know that what you know and don't know.